math analysis students, we're talking about combinations and functions today. So let's go ahead and get started. So arithmetic combinations of functions, this will look familiar to you once we start talking about it. So just like two numbers can be combined by addition, subtraction, multiplication, division, two functions can also be combined to create new functions like the sum combination, the difference combination, the product combination of functions, and the quotient. And remember, the sum, it means we added the two functions. Difference is minus, product is multiplication, and quotient is division. So let's talk about what that is. So let's talk about the domain. Remember that the domain is the input into those functions. So the domain of a combination of functions would be all real numbers in both domains of both function f and function g. But keep in mind, but is restricted on where f of x is divided by g of x, because if that's the case and it's a quotient function, g of x could not equal 0. Okay, so let's talk about this. So f and g can be two functions overlapping domains, complete the following arithmetic combination. So we know that the sum function, or f plus g of x, can also be written as the function of f plus the function of g of x. For the difference function, f minus g of x can be also written as f of x minus g of x. For the product function, we can take the function of f times the function of g. And for our quotient function, we're going to put f of x divided by g of x. But we also know that g of x cannot be 0 because we can't have an undefined number. So graphing utility also means graphing calculator. You're going to put this in your graphing utility, you're going to say, okay, like let's say you've got a function of f. You're going to say y1 equals whatever your f of x function is. On your y2 function, you'll define that as whatever g of x is. To make a combination of these functions in your calculator, you're going to say, okay, now that I have those two functions that they gave me, I'm going to say y3 is whatever I put in for y1, and you can tell your calculator to do this, let's say, and then y2 is the sum. So that would tell me that the function in y3 is the sum of the functions in listed, the rows y1 and y2, and we'll show you how to do that in class. So let f of x equals 7x minus 5 and g of x is 3 minus 2x. Let's find f minus g of 4. So remember first, before we look at any of this, all of this can be rewritten as f of 4 minus g of 4. With that said, I can find f of 4. So I know f of x is 7x minus 5. So f of 4 is going to be 7 times 4 minus 5. We get 28 minus 5, which is 23. And g of 4, we're going to plug into here. We get 3 minus 2x, where x is 4. Simplify, we get 3 minus 8. We get negative 5. So if I plug these in, 23 is f of 4. And negative 5 is g of 4 right here. Bring down the minus sign. So I get 24 minus negative 5. We add the opposite and we get 29. Oh, pardon me. This is supposed to be 23, which is going to be 28 here. All right, let's talk about compositions of functions this time. So now for compositions of functions, we're replacing what the input is here. So remember, when you're dealing with f of x, whatever's there is your input. Now your composition, f of g of x, can be rewritten as f of g of x, where this is now your input that you're sticking into f of x. So for the composition, the domain of f of g is whatever the set of all that are in the domain of g such that, so as long as g of x is in the domain of f. So the reason why we call it that is because now that g of x is the input, we have to make sure that whatever g of x is in the domain of what f can be. So let's do that example. So if we say f of x equals 3x plus 4 and g of x is 2x squared minus 1, let's go ahead and calculate. Let's do part A first. So f of g of x can also be written as f of g of x, where we put it inside, okay? So if f of g of x is really, well, f we can say, and I always say write the outside first. So f is really 3 times x plus 4, right? 3 times x plus 4. But instead of x, I'm replacing it with g of x. Well, we already know g of x is 2x squared minus 1. So now we've substituted in for the input. Now we can just simplify this. So this is 3 times, and then we're going to simplify. This becomes 6x squared minus 3 plus 4. Simplify it, we get 6x squared plus 1. So that's our f of g of x. Let's do part B. We're looking at g of f of x, which we know can be written as g of f of x as your input. So remember, we're going to write our outside function first, so 2x squared minus 1. So remember, instead of x, we're plugging in f of x, which is 3x plus 4. So now that I'm going to do this, okay, well, I know that this means I'm multiplying it times itself. So we've got 2 times 3x plus 4 times another 3x plus 4. That's what the power of 2 is. So now I'm going to FOIL this right here, and we get 2 times, I'm going to make this a little smaller, 3x times 3x is 9x squared. 3x times 4 is 12x. Another 4 times 3x is 12x. And 4 times 4 is 16. Bring down the minus 1. If we simplify all that, and then we need to distribute here, we end up with 18x squared plus 2 times 12 is 24x plus 24x plus 32. And then all minus the 1. So we end up with 18x squared plus a total of 48x plus 31. And that's your g of f of x. That's all for our notes today. We'll come back to the applications in class.